before we join other conference attendees for lunch upstairs before the main conference. Now, speaking of funding, so indeed AHRC has generously supported the project, including this event. Time is money, we have little of either, so without further ado, let me introduce our keynote. So it's a great pleasure to have George Musser here. George is an multiple award-winning science writer, a contributing editor to Scientific American, and the author of a couple of books, most recently, 2015, a lovely book on quantum non-locality, spooky action at a distance. Very nicely displays George's broad interests in physics, quantum physics, including historical and philosophical dimensions, methodologically very reflective writing, and beautiful book to read. So, George, take it away, please.
Thank you. And what do I do after such a generous introduction? I really I'm honored to be here talking to you, and I understand that this is the typical kind of weather that we have in Leeds, so I'm honored to have that as well. I'm hoping to meet all of you over the course of this event, and I'm not sure how many people I've already met here, so if at some point in my talk you want to interject with questions, feel free to do so, but just identify yourself and then we can all get to know each other. This is sort of like, my goal today will be to talk to you as colleagues, as though we were actually having a beer or coffee that's actually rather better than this coffee I got from the machine a few minutes ago. The question is, why is quantum physics so hard to write about? And I don't think that there's going to be a simple answer, let alone a single answer to that, but I'll just offer you a few of my thoughts and then we can have a discussion. I'll talk for maybe half an hour, 35 minutes, something like that, and then we can have a more general discussion. And I'm going to assume that you have written about quantum physics at some point in your communication careers, and that we're going to be trying to make sense of our common experience having done so. I was just at a total solar eclipse a couple weeks ago, and ever since then I've been oohing and ahhing and thinking about the experience I had at the eclipse, and I've been trying to process that. And likewise, we'll be processing our experience writing about quantum physics. Let's see. I'm going to assume that also, not assume, but I'm going to speak to you as journalists today, as communicators. I know that some philosophers have infiltrated into the room. I know that at least one physicist has infiltrated into the room, and that's okay. Welcome as well. One of my themes today is that actually educators in physics, philosophers, journalists actually have a lot of overlap in the difficulties that we face on the topic. So I think my comments will be applicable to everybody, but there will be times in which I'm speaking specifically to you as a journalist or someone who has written for the public on this topic. I think that philosophers, especially philosophers and journalists, we approach physics as interested outsiders. So there's kind of a commonality, at least between those two professions. Sometimes actually philosophers disagree with me, if you will, and we can get into discussion. Sometimes you act as journalists. You act in a repertorial capacity, observing the practice of physics, commenting on it, trying to make sense of it as someone who stands outside that profession. And journalists, sometimes we have to act in a philosophical capacity, interpreting the things that we are learning from the physicists, and sometimes offering interpretations of that. So just as an introduction to me, so you know who's speaking to you, I've been a science writer and editor for something like 20 years. I was just under 15 years at Scientific American magazine as a senior editor, basically a features editor there. I left a few years ago to work on that book that Juha mentioned, and I've also been doing some freelance projects for Nautilus magazine, Scientific American magazine, Eon, Quanta, and other outlets as well. And I have an earlier book on quantum gravity as well, which I'll be referring to. So like a lot of us, I think certainly with anyone in science communication has their own story of how they got into the discipline. And maybe everyone is unique in that way, so I'll just offer my own background. It wasn't something I planned to do. I was actually a science student. I was doing my postgraduate studies in planetary science. My dissertation was going to be on the planet Venus. Also a little bit on Mars. The Mars part, unfortunately, the spacecraft that I was going to take the data from ended up landing in Bolivia rather than on Mars. So no Mars chapters in my dissertation, so I focused instead on Venus. That's something that happens in the field of space science. It's just you go with what the missions are doing. But even in those days, and actually even as an undergraduate student, I took classes in philosophy. So the big questions, capital B, capital Q questions of science and intellectual life always animated me. And I've kind of moved more in that direction over the course of my career. I think that's one of the great things actually about doing science communication in particular is our ability to dabble in different areas. I love scholarship, I love drilling down as well, but the nice thing about being a science journalist is you can move around different areas and explore and indulge your different interests. I hadn't started off writing about quantum mechanics. That's something that really came to mid-career, only maybe about 10 years ago. I'd taken a course in it at university level. I talked to friends, I read the books, I read the articles. We had the late night discussions over here and everything that we all have. But it was only really, actually just before I started working on my first book that I really drilled into the subject as a writer and began to encounter some of the difficulties that I'll outline for you today. The book was on quantum gravity. It's actually called The Complete Idiot's Guide to String Theory. It's in the Idiot's Guide series along with Idiot's Guide to Billiards, Idiot's Guide to Investing, Idiot's Guide to Buying a House. So it was actually the first time the Idiots series, there's also a Dummies series as well, had tried to deal with an intellectual topic. And actually they've stopped doing that. So I don't know, I guess it didn't work out too well commercially for them. But with the quantum gravity side of things, I figured I needed to explain quantum. So I wanted to write a chapter, I dedicated a whole chapter to this on quantum mechanics and quantum field theory. And I wanted to approach it in a different way than I had read. So actually, I went to my first philosophy of physics conference at the University of Maryland on this very topic. And I spent a few days with Carlo Rovelli down in Marseille talking to him, a physicist who's also very philosophical in his thinking, and talked to him about how to write about quantum mechanics. And I have to admit, I look back on that time being very naive about quantum theory, about what made entanglement, EPR, Bell, and these kinds of phenomena weird, and being naive about what a wave is in the context of quantum physics. And I think partly my education to that date had kind of failed me, and had taken specific like single particle cases that can mislead you about the deeper meaning of the theory. And I've been kind of working through that ever since. Now, I should say, as kind of a disclaimer, that when it comes to writing about quantum physics, I don't want to be too much of a martyr. We don't want to say, oh, it's the most difficult thing ever, just as we have a very presentist view. This is the most complex period in human history. So I think that all areas of journalism, as all periods in history, have their own issues, their own difficulties, challenges, etc. And in many ways, quantum physics actually, I think, is easy to write about. It has a reputation of being hard. But at the level we're writing usually, it's not super difficult. The maths isn't usually necessary for us. Even if, for some reason, you needed to dive into the maths of quantum physics, you could probably get by with algebra and some geometric insight. And if you don't believe me, Scott Aronson, in his book, I think Quantum Computing Since Democritus, has a chapter. You can find it online if you search, I wrote it down, Probability Theory with Negative Numbers. And he kind of works through quantum mechanics in a very simple way that I think is very intuitive. So you don't actually need the Schrodinger equation and all those kinds of things to do interesting physics with quantum mechanics. The Bell theorem, I think you can get by with just a Venn diagram. So if you're just careful in your thinking, you don't need full-up maths. In any event, quantum mechanics, I don't think is a subject like molecular biology, climate science, that has a million little details. Even the jargon in those fields is hard. I don't know if anyone here in the room is a biologist. I admire you because I just can't keep track of the proteins, the enzymes, genes, organelles, pathways, everything you need to just memorize to write about biology, at least molecular biology. Also, I think that unlike political journalism, at one point actually in my life I wanted to be a political scientist. It's one of those many diverging pathways I ended up not going down. And unlike someone who covers politics, our sources, when talking about quantum physics and physics in general, science in general perhaps, are usually quite happy to talk to us. There's not a handler you have to go through. There's not a sense in which you are being manipulated by them, as we've seen with all our politicians. They're usually quite straight with us. Perhaps in the field of biomedicine, where there's a lot of money at stake, you have to be a bit careful about the motivations of the people you talk to. But usually in physics, science, pure science at least, people just want to explain what's going on. We're all in this enterprise of understanding nature. That said, these easy parts of covering quantum physics explained, I do think that I spend more time per word writing about quantum physics than almost any other subject I've ever written about. I've written about a huge range of subjects from economics. I wrote a piece on child soldiers some years ago. I've covered a lot of areas, and quantum physics really does sap it out of you. It is a challenging subject in this way. So why is that? That's what I'll be exploring. So a week or two ago, I was collecting my thoughts for this event, and I realized I needed a concrete test case to just reflect on the difficulties of this area. So I set out to write a little blog post. There had been a recent Physical Review Letters article on entanglement and its meaning in theories that go beyond the classical theories. Philip Ball had tweeted it. I don't actually keep up with the literature in the way I used to. And this is actually another issue that we can get into in Q&A. There was a time, 8-10 years ago, that every day at 2 o'clock, I would print out all the physics archive abstracts. You could actually do that. There weren't that many of them. I would take them down to the local Starbucks and have my espresso and read it for 45 minutes. I could read every single abstract in the entire physics, and that's not possible anymore. I mean, if you try to print them out, it'd probably be about that thick these days. So I don't keep up with the literature in the way I used to, and I think it's hard to do that. But that's a challenge that's not specific to quantum physics, so I won't address that anymore. But if you want to talk about how we find stories, we can do that in the Q&A. So in my little test, these were the kind of parameters I set myself. I wasn't being paid for this article, so I didn't want to invest a lot of time in it. It was just doing it for you guys, and I love you, but I didn't want to invest a huge amount of time in it, so I tried to minimize my effort on the blog post. Usually, when I do this, when I cover quantum physics, I do some great synthesis. I work on it for a month, talk to 1 million people, read a lot of papers, but this time I wanted to just keep it to a bare minimum. So I broke a lot of my usual rules as a journalist. One of my rules as a journalist is I always conduct live interviews with people, either by Skype or better face-to-face. I think there's just no substitute for talking to someone just in person. You get a better interaction with that person. They can see where you're confused, etc. You get little details about their life, their office, what they're like as a human being, which I think is important to our understanding of the subject. In this case, I didn't do that. I short-circuited that process. I just emailed the lead author. I looked at the paper, emailed the lead author, emailed a few other people, and just collected my thoughts on that. I didn't even pitch this to an editor. That was another level of complication that we get into as journalists when we talk about quantum physics. We have to convince the editor of the publication, or I was an editor, so you have to convince me that that's a worthy topic to write about. And that, in quantum physics, can be very difficult. They're like, quantum physics, do we really want to write about that? It's so abstract. And you have to talk that person into it. I didn't want to do that in the interest of saving some time, so I didn't. So I did my limited degree of investigation reporting on this, and I wrote up my little blog. What did I learn? What were some of my lessons? I'll give you 6 of my lessons and then discuss them a little bit. Lesson number 1, it's very difficult to minimize time. So I set out with the explicit goal of minimizing my time and failed, because I spent the better part of a day really working on this little story. I probably made it harder on myself in trying to minimize the time, because I probably could have just Skyped the lead author and sorted everything out in 45 minutes as opposed to hours and hours of going back and forth on email. So lesson number 1 is there's a quantum of time when it comes to writing about quantum physics. You have to put in the time. I don't think there's any way around that. Lesson number 2, the paper was so confusing. It's so confusing. I mean, how many people have encountered that? It's just, you look at some of these papers and you just can't, I mean, even when they're well written, sometimes they're written in a context that's hard for you to make sense of. Partly, I think that's because it was in Physical Review Letters. It's a notoriously kind of compressed format. I guess it's 4 pages or whatever it is. But in general, I think it's hard to get the story from papers. And I'm not probably giving you anything that's new to you if you're familiar with academic papers. Academics are complaining about academic papers, that the process of discovery is kind of told as a just-so story. They're very formal. You have to do this, then this, and this. A lot of it is left out of the papers. Often, I mean, correct me, those who are professors and lecturers here, you probably get a lot of your ideas through talks and just informal discussions as opposed to actually reading a paper, I'm guessing. Although God knows talks are also a flawed medium. But we're stuck with papers. We're required in this subject to really look at the papers, try to read them. The news stories that we write are often pegged to papers. They're in time. We're writing them because of the publication of the paper. Researchers refer to their papers. You're forced as journalists to read papers. So that adds to the complication of covering this field. Lesson number 3, and this is now I'm trying to get more specific into quantum physics. Lesson number 3, I found myself engaging in what I call a hypothetical deductive mode of reporting. And you may have some experience with this yourself. Normally what you expect from an interview, this is what you learn. I mean, I started writing for newspapers when I was actually in secondary school, and then certainly in college and beyond. The standard idea of an interview of somebody is the person you're interviewing talks, you write down what they say, you ask them questions, they talk, you write down, and so forth and so on. It's fairly linear. That's the idea, at least. But in quantum physics, I find they're highly nonlinear discussions. I can't get an answer often to the questions that I'm asking. So I find myself putting forward my own interpretation. I say things like, if I follow what you're saying is blank, is this what you mean, blank? And this is probably not entirely kosher journalistic practice. It's not something that a professor in a journalism school would encourage you to do, because you want the person to say things in their own words. But I find sometimes you need to prompt more than you do with other areas of that journalists cover. And this isn't any reflection on the scientists that I'm talking to. They are very much keen on getting their story out. Most of them are people who teach, as their profession is to pour knowledge into empty vessels, such as my head. But the things that interest them, that excite them, are not the things that excite me, that interest me necessarily. So all scholars work in some kind of context. They work in some kind of problem context. They're contributing to some scholarly project. That's what they're doing. But as someone standing outside the field, you're not so interested in that particular jigsaw puzzle. You're interested more in the basic problems that humanity is facing, what the research means for something like technology or for understanding of nature. The technical accomplishment that sits in the middle between those two is of less interest, ironically. But that's, of course, the thing that's of most interest to the scholars, so there's a bit of a disconnect there. This is something else you might recognize. Scientists are very worried about how their colleagues will see what they say. They don't want to look stupid. This is especially true of, I think, younger postgraduate students, postdocs, and so forth. As you get older, you kind of lose your worry about looking stupid. Again, with exceptions. But sometimes we want, don't take this wrong, you want stupidity. You want someone to explain things in a very straightforward, simple way that you can then turn around to the public and say, aha, this is what it means. And it's sort of like negotiating for a carpet or for a car. You want to underprice. You don't want to say the real price that you want to pay for the carpet or the car or the house. You want to kind of underbid it. They come in on top and you negotiate and you get somewhere in the middle. Likewise, you almost have to ask a question at a kind of a stupid level in order to get the answer down to the level you really want. So colleagues, academics who are afraid of looking stupid in front of their colleagues is an issue because they're not speaking ultimately, they shouldn't be speaking ultimately to their colleagues, they should be speaking ultimately to the public, and that's a very different audience. Lesson number 4, what do you lead with? What do you start the article with? How do you do it in a fresh way? So if you've read, written, looked at a lot of popular level articles in quantum mechanics, you start to sound the same after a while. I don't know what your experience is. It's the usual narrative goes something like quantum mechanics is very mysterious. Nobody understands quantum mechanics. Insert quote from John Wheeler, insert quote from Richard Feynman. Einstein was left clueless by quantum mechanics. This is the most convenient narrative. Quantum mechanics is weird. Quantum mechanics is beyond us. And it's put to you as kind of a gee whiz kind of story. We play that up, I think, because, as I'll get into a little bit later, for lack of other narrative possibilities. but also because it makes for a dramatic story. I even did that with the title of my talk today. What was the title? Why is quantum mechanics so freaking hard to write about? So I'm kind of playing that game myself here. I'm kind of playing up the difficulty a little bit in order to make it more dramatic. But it gets very hackneyed when you do that. In fact, worse, I think sometimes we start to believe our own rhetoric. So we want this narrative to be quantum mechanics is difficult to write about, reader. And then we start to think it's difficult to write about because that's what we've just written. And we get ourselves in kind of a loop. I try to resist this tendency, although I admit I fall into it as much as anyone. I try to tell stories in a fresh way. For that little PRL blog post, I emphasize I have a landscape of theories. In addition to quantum mechanics, that quantum mechanics is one of a family of theories. Anyway, I was trying to de-emphasize the weirdness part of it for this case, but it's difficult to find that kind of narrative, and I'll return to that issue a bit later. Lesson number 5, I showed my little post, the little post I was about 1,000 words I ended up writing on this paper to some of my editor friends. And they said, George, it's very well done, but if you really did want to publish this, you would still need to do more work on it. And that's another level of complication with writing about quantum physics. Even when you think you understand it, even when you think you've seen its greater context, that's still not enough. There's only so much that you as an individual writer can do. And you have to work with editors and friends and colleagues and so forth to hone it. And I think there's actually a deeper issue here, which is we're kind of in a catch-22 when we write about certainly new results in quantum physics. As journalists, almost by definition, we're interested in new things. If you ask an editor, do you want this article, he or she will ask, is it new? Is it a recent discovery? Scholars may not like that kind of approach, but that's kind of baked into the journalism enterprise, this newness. But the things that are new are necessarily the hardest to interpret. They're new. They haven't gone through a cycle of telling and retelling. So when a scholar, a scientist publishes a result, and if the result is substantiated, it will then be retold multiple times. They will tell it to their colleagues who will retell it to their other colleagues, and there's a chain going out. It'll be in survey papers. There'll be kind of a collective processing and reprocessing of this result. And with each cycle, it gets a little bit more comprehensible. So you see this especially with the understanding of entanglement. I mean, EPR paper, 1935, even that came out of Einstein's earlier discussions about, it wasn't even named entanglement by that point, about composite systems in quantum physics, going back to at least 1930 or probably even before. And then he codified that, or he and his colleague codified that in the EPR paper in 1935. Then John Bell, 60s. Of course, I'm actually leaving out some intermediate steps, but for my purposes, John Bell in the 60s came up with his theorem, his inequalities. They went through many cycles of being analogized, not just by John Bell himself. David Berman was another player in this. When I went to write my books, I came up with my own metaphors for these ideas. So you can see over the course of decades, there was a slow rethinking of topics that for a news story hasn't had time to occur yet. So you're necessarily at the hardest point in the cycle of retelling. What that often means is you end up telling old stories. You end up actually breaking out of the journalism mode and telling, so how many times have Einstein-Bohr debates been written about? How many books are there on the Einstein-Bohr debates, even just from 1927? Dozens. Just as I was working on a little post of mine, Philip Ball published, I don't know if anyone saw an article in Quantum magazine on efforts to axiomatize quantum theory, to kind of boil quantum mechanics down to a series of basic principles that supposedly make sense, and then you can extract the whole formalism from that, which is a great story, but definitely not a new story. That work goes back 20 years or so. And finally, lesson number 6, and then I'll riff off them a little bit. All that said, all the complications, challenges, compromises aside, I think it's worth it. It's just a fun area to write about. So I don't want to be too down on it. I wouldn't be in this profession if I didn't think that it was worthy to write about it. The authors of this particular PRL paper said they loved my little story. I didn't want to invest any more time in it, so I just posted it to my personal blog. And just some context, I have this little personal blog I set up actually a couple years ago. I don't promote it on social media. It's just basically, who reads it? I mean, nobody, essentially. I got over 1,000 hits on this story on my personal blog, despite the fact I don't promote it hardly at all. How did people even find it? I don't know. So there's a hunger in the public for articles on the issues that we write about. And I think that's just really, really gratifying. When I was at Scientific American, quantum physics, put on the front cover, was one of the best sellers that we would have just on a commercial basis. That, cosmology, and human origins were really the top three areas of interest in this commercial sense. I think you scientists have told me a similar thing. And this is what keeps you going despite these various difficulties. So let me generalize and elaborate on a few of the points that I learned in my little test experiment, my little blog post that I wrote a couple weeks ago. I did it for you guys, so I hope you appreciate it. As I said at the outset, I don't think quantum mechanics is that much harder to write about than other areas. It has its difficulties, of course, but so does every subject. But it can feel harder. So what's the origin of this feeling of difficulty that it has? And probably the first thing that would come to your mind is it's very abstract. So when we humans understand something, we have to integrate it into our existing web of knowledge in our head, and it can be difficult to do that with this subject because you can't find a connection point. You can't. It's like a jigsaw puzzle piece that sits over here, and you can't put it into the rest of the puzzle. Part of that is it doesn't lend itself to the usual narratives that we humans use and that by which we make sense of life. It's not. There's no real human narrative, but again, with exceptions I don't get into. There's no often a chronology. There's no story of someone going to the South Pole and risking life and limb to bring back the neutrino data, that sort of thing that you get in a lot of science stories. There's no overcoming great personal adversity, the kind of Stephen Hawking tale. Lives, this isn't like cancer research where lives are being saved. So you're kind of in what I would call story-poor environment with quantum physics. Physics, it's generally, to some extent, but certainly quantum physics. Even in the lab, I've done sort of mini sabbaticals where I've been in laboratories with a coat on and the whole thing, and I've really had fun doing experiments. But there's not a lot to see in most labs. The thing that I actually remember the most, that stuck with me most, was just seeing a single atom glow. I was kind of held in a trap, and you can actually see the little single atom glowing. And that was kind of a trip, seeing a single atom. But otherwise, there's not a lot to see in these labs. Even a lot of pictures that I published and that you see are often doctored just to show and make them more dramatic. Now, there are exceptions, of course. We all, as journalists, historians, try to tell human stories. We look for the human story. We look for the larger-than-life characters. This is why I think the pioneers of quantum mechanics, their stories often told and told again, because God knows Einstein, Bohr, Schrodinger, they're all kind of larger than, at least from our distance, are larger than life of figures. But even today, we have some really interesting personalities. I've written about Nimar Kani-Hamed, for example. Very interesting person. But even when you do that, even when you write about an interesting person, you're still having to weave the physics into the story, and you still encounter all the other difficulties. It doesn't really get you out of the conundrum. So it is almost a cultural expectation that quantum mechanics is hard to write about. And we writers shape it, but we're also shaped by it. So we're kind of in a bind here, I think. We need to overcome this barrier of abstraction and appeal to people on this topic. But we don't want to talk down to people either. You could try to be cutesy in it, but you don't want to talk down. I think one of the great mistakes we make, certainly in science journalism, probably journalism generically, is we tend to underestimate our readers. Our readers are quite able to process abstract, difficult information. And they do that all the time. When I wrote a lot more about space, I think it was just easier because you're talking about rocks. You can imagine landing on Mars. You're looking for life in the universe. There's a natural template of a story there that we lack in quantum physics. But people are quite able to handle quite technical detail about space. AI is another area. Again, you see a lot of stories on this that can actually get into some really nitty-gritty in a way that in quantum physics you go, whoa, if I did that in quantum physics, people would just be lost. So it's a question of really overcoming readers' initial distancing themselves or reluctance to get into the topic. But once they're in the topic, they're good, actually. They can take it. And I find there's kind of a bifurcation of readers on this question. So group 1, group 2. Group 1, they're the ones who see the word quantum and they freak out. Oh my God, it's quantum. I'll never understand it. My wife is still like this. Bless her heart. Even after all these years of my making her read things, she's still like, I don't want to read this. It's about quantum mechanics. It's weird. She's an English professor, so her specialty is literature. But even so, once she's in it, of course, when she gets over the kind of fatalistic barrier to entry, she's actually quite happy. Wow, this is so clear. It's so well written. So I think if people stick with it, they're grateful. Probably because their expectations are so low that you can't help but exceed them. Then there's group number 2. And this group you may recognize. They're the ones who say, quantum mechanics is really hard, and I like that. A lot of people like readers like quantum mechanics because it makes them feel smart to read it. It's great. I love these people, but they have a tendency to want to show off how smart they are. This is where it gets a little tricky. They do that often by trolling you. And I have to admit, I need to stop reading my Amazon reviews. I get into a lot of trouble on this, but boy, people are very hypercritical. They're like, they find what you think is one tiny little mistake and they blow it up and they give you a single star, these kinds of things. So they want to show how smart they are. And I probably was like that when I was, 8 years old or so. I remember, I think I read the article and they got the distance to Mars wrong. And at those days, I actually memorized all these distances to different planets. So they got it wrong. And I wrote in, triumphantly, you got the distance to Mars wrong. I mean, you kind of, at some point in your life, want to do that. But hopefully, when people grow up a little bit, they get over it. But some people don't. These people in the group 2 actually don't like metaphors that much either. Even metaphors that physicists and philosophers use in discussing quantum mechanics, they don't like. So I use a coin metaphor in my book to discuss entanglement. So I think of 2 particles as 2 coins that kind of, when you flip them, their outcomes are correlated. And there's other metaphors that one might use. But I'm not the first person to use that metaphor. And I've taken to task. George Musser has used this coin metaphor. How dare he? He shouldn't use metaphors. He should talk about particles with spin or whatever. So these people are kind of literal-minded. And they're always men, I have to say. There's probably some male status display going on here. Sometimes I get a nice email from somebody in this group, and they say, I really love your article. And this is where I really need to brace myself, because then the next thing out of their mouth is, because it confirms my own theory. When I did, long before, actually one of my first things at Scientific American, I did a special series of articles on the accelerating universe. This is back in '98 with the discovery of dark energy. We got so much mail, and this is back in the days of actual paper mail. We actually, I think, filled a box like that deep with the mail we got. And usually there were 80-page dissertations on why the dark energy proved their theory. It was amazing. Anyway, sometimes I say to myself, why do I bother? These are supposed to be my people. I'm writing for them. Why are they so hypercritical or so just plain weird? But then my faith is restored by the first group. They're the ones who just love everything you do. So it's just kind of an emotional seesaw you can go on. So quantum mechanics, as I said before, I don't think is that difficult, but it is very subtle. It does require thinking that in some cases you have to do over decades, or humanity collectively has to do over decades. This is why it's fun to write about, actually, arguably. But it's an area where misconceptions can spread. And this is actually one of the reasons I think coming to a philosophy conference is so useful, because philosophers are zeroing in on misconceptions and clarifying understandings as well. Let me just mention 3 of mine. 3 misconceptions. I probably made them even, but certainly that irk me when I see them. So don't make the same mistake. And actually, there's a common element to these 3 misconceptions. They all come from the confusion about what is interpretation and what is formalism, or what is kind of the mathematical theory. One interpretation is Einstein hated quantum mechanics. He didn't, actually. Or at least his thinking about it was more nuanced than the word hate would connote. For the first couple decades of the development of the theory, he was ahead of everyone else. People didn't believe him. He would say, hey, there's this thing called the quantum of light. No one believed him. Bohr didn't, famously. What he did dislike was the interpretation that Bohr and Heisenberg were trying to impose upon the theory, what eventually later kind of became packaged into what we call Copenhagen. So there's a lot underneath that name. Einstein thought physics should be local. There shouldn't be action at a distance. So he had misgivings about the theory, but that were shared by all of his colleagues. None of them thought there should be action at a distance at the time. So what differentiated Einstein was not his dislike of quantum theory per se, but his recognition that the interpretation was somehow wrong. And I elaborate on this a little bit in my book based on work of like Don Howard, Mara Beller, and others. The bottom line is, stop using Einstein as a punching bag. It's tempting, but there's a story beneath that characterization. Misconception, or perhaps nuance number 2, is that quantum mechanics is fundamentally random. Again, that's an interpretive question. The phenomena present themselves to us as random, but what's underlying that is less clear. And how you marry phenomena to formalism is where you get in and launch these 1,000 interpretive ships. So it's really an unresolved question. And then one that comes up a lot is quantum mechanics is a theory of the small things. Just last week, The Economist. Quantum mechanics is a description of how subatomic particles behave. True, technically, but it's actually a description of how everything, or at least it's thought to be by most people, a description of how everything behaves. We're quantum mechanical objects. As much as a particle is, it's harder to see that, but that's not really because of our size, it's because of a process of decoherence, which is related to but not the same as size. And the reason I harp on this is I think when we emphasize the idea that quantum mechanics applies to the small, that we're kind of making it an esoteric theory, so we're contributing to this whole sense it's weird. And I think that's kind of working against our purposes. So this issue of interpretation is quite crucial. It's kind of the fun of discussing this subject. So you know about the observer effect, the idea that it's not actually restricted to quantum mechanics, but we often talk about it in that context, that by observing something, we affect it. I think that's actually the case with us as journalists. When we write about quantum mechanics, we end up affecting the practice of the science. We become part of the interpretive project. So physicists are great at mathematics, experiment, often not so good at interpretation, with exceptions. They often haven't done the interpretive work on their own theory. This is where the philosophers really, this is your role as philosophers, to do that work that sometimes is left to the side. But the interpretive work is what is most interesting. Well, leaving aside the technology like computers, cryptography, what interests readers the most about quantum mechanics is really knowing what it tells us about reality. They are curious about that. And that's the one thing physicists are least prepared to provide us. We journalists are often the first non-experts that the physicists have ever talked to about their theory, their new analysis, or what have you, which is great for them. They're happy to have that opportunity. I think physicists, bless their heart, have an ethic of physics concepts should be explicable. They should be able to write on a t-shirt. They should be something we can explain to grandmothers and grandfathers. But it does complicate your task to be engaged in that kind of dialogue with them, to get to the point where you can explain it to your grandfather, your grandparents. This is, I think, what's really the main challenge of my second book on the topic, was drawing out interpretation from physicists. Especially for quantum gravity, by the way. Especially for holographic principle, non-commutative geometry, even parts of quantum field theory. Drawing that interpretation out of people was difficult. But that's the niche of philosophers. That's why we are here, I think, at this conference. And I would recommend, I'm not just saying this because there are philosophers in the room, I would recommend that every journalist writing about quantum physics have a philosopher on call, someone they feel they can ask an interpretive question of. You would put in your Rolodex, so we still live in the era of Rolodexes. Whatever the modern cognitive or Rolodex is, have a philosopher in that. Not to say the philosophers are always clear, present company accepted. Sometimes I don't get philosophical papers because of my own thick-headedness. They're too abstract for me or too deep in the weeds. Just to give an example that's not from quantum physics, I just read a wonderful book, actually, by John Searle on the philosophy of mind. Actually, the book is just great. But it has a 30-page chapter on intentionality that just left me wondering what I had just read. I didn't get it. It didn't help that the word intention is being used here differently than in vernacular language. But he never really explained why this intentionality. Maybe someone can help me with this later in the meeting. Why intentionality is a puzzle. Because he assumed it and then launched into a 30-page explanation of how to solve it. And I just was left in the dust from page 1. So philosophers often work in a kind of a historical context that if you're not a philosopher or haven't read it in university, you're just left out. So interpretation is the most contentious part of, oh wow, I'm really going over time, so let me be quick about this. This is actually the last section before we get into a general discussion. Interpretation is the most contentious part of quantum mechanics, and it's the human saga of quantum mechanics, but controversy, contentiousness, is difficult to write about, just inherently, as journalists. And I think we as journalists should always be talking, reflecting, re-examining how we cover controversy. It's our bread and butter, and often we don't do it very well, frankly. So we need to think about it more. One thing that makes quantum physics controversy, and usually controversy is over interpretation of quantum physics, but it happens, experimental results or any other aspect of it can be controversial. One thing that makes it tough is the difficulty of the controversy comes in addition to all the other difficulties of covering the subject. So I talked to Alice about her work. She explained it to me. I think I've got it. I talked to Bob about his work. He explains it to me. I think I got it. I could write up an article about either one of their two ideas. I think I've grasped it. The problem is they disagree with each other. So that disagreement is kind of a higher order level of knowledge I need to have to understand. I can summarize their disagreement, even though I get their individual positions right. If someone regards their disagreement, I might get it completely wrong. So I compare it to a process of subtraction. I need to look at the difference between their positions, and subtraction is an arithmetic operation that magnifies error. If you have two numbers that are imprecise, the difference will be even more imprecise. It could be the sign is wrong even. So I think that often happens with our coverage of controversies in science, not just quantum physics, but generally, that they require a depth of knowledge that sometimes you don't have on the field or you can't acquire in the time you need to write about it. It's a problem not just for the journalists, I should say, for the scientists. So I don't know how many times I've had this conversation on quantum physics. Alice, why do you disagree with Bob? She'll say one thing. Bob, what about this disagreement with Alice? He'll say one thing. Different things again. They disagree on how they disagree. So a lot of these debates just get stuck. They get stuck in place. I'm actually struck by how few open debates occur in quantum physics and the understanding of quantum physics. Maybe more philosophical meetings where there's that idea of commentator on papers, but you don't really have that in physics conferences. There are very few times where really people disagree, go at it. I've gone to conferences expecting, I've flown specifically to that conference to get a fireworks display, and people are silent in the questions and answers. It can be very frustrating to try to make sense of a debate that even the protagonists aren't making sense of. And this is all with other areas of science, climate science, any area like this. The debates usually occur in papers, reviews, peer reviews. You don't see those, book reviews, a third party, but seldom in direct public exchange, and that's not just in physics. I was listening to one of Sam Harris's podcasts recently. I think it was an older podcast of his, but he had Dan Dennett on the podcast, and they were going to talk about free will. So Harris and Dennett have different positions on what does free will mean. And they were getting in the podcast to do exactly a meeting of the minds. That was the purpose of he had an hour-long podcast, so they would be able to just hash it out. And guess what? They didn't. I've never had a more frustrating hour of listening in my life. They just talked right past each other. It was amazing to listen to. And these are two smart people motivated to have an exchange that they failed to have. And you get that even more in other domains of physics. And I can, for interest of time, I won't go into some of the other examples that I've provided. I will mention that I think there's a kind of a paradox of what I call a paradox of skepticism. It's probably not a technical paradox. The tension of skepticism. Scientists default to being skeptical about new results, about things their colleagues say, ideally about what they say, though that sometimes doesn't happen. And the skepticism, at some level, makes a lot of sense. Most new ideas in the world are wrong, or certainly in any emerging, vibrant field, they will eventually be proved wrong, because that's the nature of the dynamism of research. So if you say everything's wrong, if that's just a reflexive position that you take, you'll be vindicated most of the time. But you'll also miss out on those few things that do turn out to be right. So, in other words, there's a threshold that scientists set in their skepticism that excludes false positives, but excludes also true positives. And I think we as journalists set that threshold differently, just by the nature of our profession. We recognize in journalism that we're writing a first draft of history. We're capturing the moment of time. We're less interested in kind of long-term questions of right and wrong, just at least read these kinds of articles. We're not disinterested completely, but we expect things to work out later. But for now, we're just going to put out the ideas as they are. So that's a tension between scholars in general, probably, and journalists, that leads to some difficulty between them. So what do we do with controversies? Again, I don't think there's a magic bullet. I have a few of my own kind of rules of thumb that I use. One is something I call the King Solomon test, or maybe the meta-knowledge test. Do proponents acknowledge their own uncertainties, the fact that they might be wrong? Somebody who doesn't acknowledge that they might be wrong is someone I tend to weight less, because science is tough, research is difficult, quantum physics more so everyone should acknowledge at some level that they might be wrong. This, by the way, comes up all in climate science. One thing I think that distinguishes the so-called climate skeptics from mainstream climate scientists, to the extent you can make that division at all, is meta-knowledge. So a lot of people, Richard Lindzen at MIT is an example of this. He doesn't think he's wrong. He thinks he's absolutely right about the fact that there will be no anthropogenic climate change. So maybe he is, but I will weight his position less simply by virtue of his lack of self-reflection. Another thing I look for is common ground. I try to do this a lot in my book. I think that often people on different sides of debate agree on a lot. And although they're in the scholarly mode of disagreeing on what they disagree on, and that's important to them, I think if you take a step back, sometimes you'll see actually not a lot of disagreement between them after all. Think about the string wars. So string theory, this is really hot about 10 years ago. String theory, loop quantum gravity were usually on the opposite sides of this debate. I think actually there's a lot of commonality between those two fundamental theories of physics. They both think, for instance, that for the most part, the effects of quantum gravity will occur at extremely high energy, therefore out of experimental range, not just for string theory. Those often portrayed as string theory makes untestable predictions. Well, the other theories do too. That wasn't often pointed out. They both think space-time is emergent somehow, so they have a lot of common areas that, to the outsider, is actually probably more significant than their differences. The wild card in handling these controversies is really, and I don't know how to handle this, so I'm interested in your thinking, is the reader. Readers come to these controversies definitely not as blank slates. They have their own ideology, their own personal experience. We Americans especially, we tend to valorize the cowboy, the heroic outsider, who will question the conventional wisdom. So often they will overweight, even when you didn't intend it, they'll overweight the outlier in any kind of debate. And we need to be aware of that when we cover these debates. Anyway, so let me wrap up, and then we can open it for the remaining time into a discussion, or also over coffee. Why is quantum mechanics hard to write about? I don't have a single simple answer to that. I think it's a confluence of factors. It's very subtle. It takes time to think about. Time is the one thing we often don't have. It's very abstract, so it doesn't fit into our usual narrative forms. It's very tempting, given the lack of narrative forms, to oversell the difficulty, to heap abuse on Albert Einstein. So I implore you to try to resist that tendency. The most interesting part of the theory, its interpretation, is also the least certain part, the most controversial part. So you're kind of having to focus on the area that is the most difficult to write about when you write about it. So it has this kind of weird structural issue. Readers have their own issues, students as well, when you're teaching student quantum mechanics. They can either be intimidated or hypercritical, or have their own kind of ideology that's coming to bear on this, even on such an abstract topic. But it sure is fun, I have to say, despite all this. I mean, what other subject gives you such a feeling of plumbing the depths of nature and really coming to grips with the deep questions of why in the world? And maybe if it got too easy, we get bored by it. Anyway, thank you. So I think we have maybe, 8 minutes for questions before we adjourn. It's up to you. It's up to you.
Yeah, let's do that. And then we can carry on the discussion over the coffee break. We have 15 minutes of coffee, and then we can, of course, return to these issues at the end in the general Q&A or discussion period we have. So, any questions to George?
Hello.
If you could just introduce yourselves, because I don't often know.
I'm Hayley Dunning. I'm a press officer at Imperial College London.
Cool.
So, I think I know the PRL paper you're talking about.
Mm-hmm.
You talked to Jonathan Rykins.
Yes.
Yes. So, interestingly, I also talked to him about this paper.
Ah.
I didn't end up writing about it because we didn't know when the paper was coming out and I ended up being away. That's beside the point. So I actually did sit down with him and talk to him.
Oh, great.
What he did was got a big stack of paper and drew me lots of abstract diagrams, which is what they tend to do. But it brings up a question about quantum physics in that a lot of it is almost best represented by a simple diagram. So how much do you try and make it all words and, overcomplicate yourself by using the words? And when do you just say, have a diagram?
That's really, really good. It depends on the project. But first of all, you're absolutely right. You sat down with them. So already that a lot of the complication went away by that direct interaction, which is one of the points I would make to everybody. When you can, even if it requires a train ride or effort to get to talk to the person, try to. It makes such a difference. So diagrams, it's tricky. So I also tend to process ideas in that way, and whenever I can, I try to present a diagram, but often you can't. So a lot of publications have a kind of a quota or just a budget for the art that they can include with an article. Scientific American had an even weirder situation. Actually had a huge budget for diagrams. It's known for that. But the diagrams had to be on an independent track from the text. So the text had, in principle, to stand on its own, which meant you had to write yourself sometimes into intricate loops to try to get away from just see figure 1. And the thinking on that, by the way, was that most readers read only the diagrams. So they would open the page and they'd read the captions and the figures, and the idea was they should get the whole story that way. So they try to make that independent. But it depends a lot on the publication. But you're right. I think we need to do more diagrams, more animations even. Animations are extremely time-consuming. I prepared a couple that I've used in talks geared to my book. It took me days to prepare them, so often we don't have that time.
You mentioned,
Sorry, who are you?
I'm Sam. I'm doing a master's course in psychology at
Oh, cool.
University of West England. So you mentioned, Carlo Rovelli.
Mm-hmm.
I read his book on quantum gravity, and he goes just all the way back to the Greek philosophers and just explains everything from there on in really meticulous detail. And I found that really interesting, but I just wondered what you think about the style of explaining it, and how might that compare with your own.
I mean, in Carlo's hands, that's a lovely style. I should say that I think Carlo, in his own career, came to that style. He kind of did the physics and then later added the kind of historical context to it. So his own thinking was a bit inverted on that. So in the sense of processing what he came up with, he then went back to some of and wrote an entire book on some of the early pre-Socratic philosophers. I mean, I like it. That's actually another way to enter the story narratively, is to connect it to prior art, as in prior art going back to the dawn of Western philosophy. There is a risk, though, that the article can then also start to sound a little cliched, as Plato and Aristotle argued. I mean, you might get into that kind of mode. In my book, I do something that even my editor objected to a little bit, but I kind of felt I had to. I did the history second. I actually had a chapter on the current work, then went back to the historical context, because I didn't want this to sound like another Plato, Aristotle said this, and we're all footnotes to that. I don't know what you're thinking on this.
Yeah, I thought it made for a really interesting read. I felt sometimes it wasn't always necessary. Like he mentions Greek philosophers all the way through, even though I don't think they're particularly necessary. They just make it more poetic. Mm-hmm. I really enjoyed it. I thought as a book communicating its science, it could have done it to less words, but I didn't put it down for that.
Great. So it worked for you, and that's an instinct for other readers you could apply.
But would you say like the historical context is like usually necessary?
Is necessary. I mean, perhaps too binary, probably not strictly necessary, often helpful, because then it's helpful because it shows that there's a continuity of thought, that this isn't just a weird thing coming out of the blue. So it's good to have that. I think it demystifies things a little bit when people see it's not just a brand new phenomenon, it has this precursor. It does humanize things a little bit to know it's part of this great tradition. Strictly necessary, probably a lot of stories it would just be intrusive to do that. You'd have to judge on a case-by-case basis. I'll come back to you later.
Hamish Johnston from Physics World. I suppose it's a related question, and I suppose not to do with quantum science, but just covering science in general. Priority, the idea of who did what. Academics are obsessed with it. The rest of us find it very tedious. Do you have any? do you have any policies for dealing with?
It's so hard, isn't it? I mean, I try really hard in the course of reporting to figure out priority. Often that spade work doesn't end up in the final product, just for whatever imperative you're under. As a related topic, academics are also obsessed with getting a co-authors mentioned because they don't want to have to deal with the nasty co-author saying, hey, why isn't my name mentioned?
And funders now.
I've had people who wouldn't talk to me after writing about their work because I didn't mention their 8 co-authors. I said, if I'd mentioned your 8 co-authors, by the way, it's not just the name, surname, it's the of, the university of. So you start to get a long paragraph of names that, as you know, can be quite tedious and can, more to the point, in print, especially where there's a limited space, eat into the space you have for explanation. So often I blame my editor, and as an editor, I would often encourage my writers to blame me and say, we just couldn't, we tried to. You can tell a story like that to assuage people, but it is an issue. And then priority issues as well, in addition to just the co-author issue. I try to ascribe priority. Often that can be difficult. So there was a cosmology story I wrote on, this is way back, and NASA's actually works with this. They had a huge press conference to trumpet the new discovery that they made. It's having to do with infrared light. And turns out that actually they completely forgot to mention the prior art on that. So I did find through the course of reporting whose work it had been. It really annoyed the press conference people that I had kind of done that. So, you just have to do what you think is right. I'll come back to you, Dave, in a second.
No, that's fine.
You're an interloper a little bit.
Yes, Lisa.
I'm also a bit of an interloper, but
What's your name, sorry?
I'm Lisa. I do various psychon things, mostly presenting, but I run a blog called People Lab. You said about quantum physics being a bit of a story poor environment, but then you also had this kind of interesting thing about the people who disagree about how they disagree. Have you ever considered or ever written an article about how people disagree about how they disagree?
I haven't written an article about it. You're absolutely right. I hope someone can run with that idea. I go into in my book, actually, I have a chapter on that where I interleave the sociological story with the physics philosophy story. But no, I haven't written any article specifically on that, and I encourage you to do so, because I think it is, and it's not just an article you would write once. It's an interesting sociology of and not just in quantum physics, not just for journalists. There's just sometimes the scholarly mechanism kind of seizes up, and you just can't get resolution on something. Is it something you've encountered?
It seems to tie in interesting with the idea of uncertainty in science that you mentioned, and how people have to kind of admit that they're fallible or that their theory might be wrong. And I guess if people are disagreeing about how they're disagreeing and that's seizing up, then that's maybe a sort of not being able to see how your theory might line up with somebody else's alternative theory.
Yeah, I approach that. There's a sense of part of me just wants to scream out, figure it out, people. But a part of me just wants to also not be so prescriptive. If this is how science feels it has to operate, then let it be. Maybe people feel that it's going to be resolved over the course of time, and that they don't have to have an individual meeting of minds. Anyway, nonetheless, it is a source of frustration and complication, I think, of writing about this.
Let's have one more question.
Okay. David, go for it.
Well, it was a quick observation, really. I mean, you said that, sorry, David Wallace, philosophy, University of Southern California. You said very nice things about philosophers of science. I mean, so here's the sort of the self-deprecating concern. I mean, the centre of gravity on a lot of physics topics, certainly including quantum mechanics, in philosophy of physics, is not quite the centre of gravity in physics proper, and in particular a lot of positions which are very niche in physics, like particular sorts of, like the bone theory, like dynamical collapse theories, which are respectable in physics but extremely niche, have a very disproportionate presence in philosophy. So how do you sort of deal with those kind of, I don't want to say axis to grind exactly, but differences of focus in getting the sort of advice you're talking about?
That's a really good point. I confess I did write an article in GRW, so that's a little bit in the lines of what you're saying. So not a strong area of interest amongst physicists, although, as you say, philosophers write whole books on the topic. On the whole, I would say no hard and fast rule. I do try to root an article or longer project in a physics initiative, and then bring in the philosopher for reflection on that. And I think you're right. If I were to do the other way around, I'd end up writing a lot about Bohm theory or the Flash ontology and things that most physicists probably don't even know about. It's a fair question. So I think the answer is, I do see myself as covering physics as a topic. And much as I love philosophy, I think the philosophy is in service of the coverage of the physics.
Okay. I think we better stop here. We can carry on the discussion over coffee and then, of course, return with questions to George
Please.
Towards the end of this. But let's thank George again for fascinating.